Okay, I debated about coming back on because we had almost finished number 6 as the video ran out. I'm pretty sure you could have done 14 electron volts minus 13.6 electron volts and gotten zero point 0.4 electron volts without me telling you that was the answer. But I wanted to come back and talk about it because there's two things that are different in this question. Whenever you're ionizing an electron, that is the only time that the EP does not have to exactly equal the level that it's going from up to the level that it's going to. So if it's going from 4 to 5, if it's going from 1 to 2, if it's going from 6 to 2, the EP always has to equal. But if it's ionizing, the EP can be bigger. And then whatever's left over really is given to the electrons to use as traveling energy. It actually is what we were doing in the photoelectric effect. EK max is equal to HF minus WO. So the EK max is really the energy that's left, the final. The HF is the energy of the photon, so it's the 14 electron volts. And the WO, it's the minimum energy needed for the surface to release an electron. So if the electron, whatever level it's in, then the energy of that level is the energy that's needed to release it. So the negative in our WO equation is already looked after. So don't put two negatives in there, right? So the 13.6 electron volts, remember, because that negative comes from the graph when we plot it. So both negatives are the same negative, so don't put it in twice. And then you'll get 0.4 electron volts, right? So these two are one and the same thing when we're talking about ionization. So when we're talking about ionization, the WO is the energy of that particular level. And if you want to just get it to ionization, then it has to be equal to the EP, which is what we did up here. But it's okay if it's bigger, because if it's bigger, the rest goes into EK max. All right, so that was why I wanted to I couldn't get it in the last one, but I wanted you to understand that really these are two separate things when we talk about ionization. The WO is really the ionization energy, the energy you need to give a surface to make it release an electron. And if the EP isn't big enough to do that, then it might jump the electrons up. And when we were looking at the photoelectric effect, we couldn't tell that. We had no idea if on that photosensitive surface, if some of those electrons were jumping up to a higher level. The only thing we could see were the ones that were totally being ionized and coming off into the evacuated tube and making it into the circuit. Okay, so now we're looking a little closer at what's happening inside the metal. Some of them are also hopping up, and then they would eventually fall back down. All right.